We are used to anticipating danger from outer space, a huge, almost unknown space hostile to humans, and no wonder colossal explosions take place, asteroids and comets travel at tremendous speed. There are black holes, and all this can potentially cause the death of the Earth. But what about something small? For example, an ordinary sewing needle? What if one finds itself in space, accelerates at the speed of light, and then crashes into our planet? Any object consisting of matter can't move at the speed of light or faster, so scientists from NASA are unlikely to ever consider such a disaster. Well, I will do it for them. Today, you'll see how dangerous such small things can be if they are properly accelerated, and at the same time, you'll learn about another strange scenario of the end of the world. Our planet is constantly bombarded by various cosmic bodies. We don't even notice most of them. They just burn up in the atmosphere. Sometimes celestial bodies manage to reach the visibility zone and even make some noise. Take, for example, the Chelyabinsk meteor, or the very asteroid that caused the dinosaurs to become extinct. But the fact is that all these celestial bodies move very slowly, of course, considering the scale of the universe. For example, the Chelyabinsk meteor was moving at a speed of 60 to 69,000 kilometers per hour. That's 37 to 43,000 miles per hour. Now imagine that one day scientists will report the terrible news. An unknown object is approaching Earth at the speed of light. It's very small, the size of a needle or even a grain of sand. If at this stage you had time to think that speed there's nothing to worry about, it is in vain. What seems ridiculous at first glance poses a serious danger to our planet. The consequences would be terrible. It's all about speed. For example, take a car. If it moves at a speed of about 50 kilometers per hour or 31 miles per hour and hits a person, the person will survive. If you accelerate the car to 65 kilometers per hour or 40 miles per hour, then the collision could result in death or serious injuries. The speed of light is almost 300,000 kilometers per second. That's 186,000 miles per second. This is very fast. In nature, visible light and other types of electromagnetic radiation travel at the speed of light, and also, possibly, gravitational waves. Scientists believe that massive-sized particles can't move at the speed of light. They can only come close to it. For example, protons are accelerated just a near-light speed in the Large Hadron Collider. So, a needle approaches the Earth at the speed of light, or a grain of sand. In general, something very small. The length of the simplest sewing needle is about 35 millimeters, or 1 4/10 of an inch. The size of a large grain of sand can reach 5 millimeters, or 19/100 of an inch. For comparison, the same Chelyabinsk meteor had a diameter of about 20 meters, or 66 feet. The difference is huge, but in this case, the size does not matter. Even a tiny object, having accelerated to tremendous speed, will become deadly. It won't burn up in the atmosphere and will not explode in flight. The bonds that kinetic energy ensure the integrity of an object will stop working. A grain of sand or a needle will simply become a bunch of atoms passing through the air. But the real danger is kinetic energy. I won't bore you with calculations. We'll immediately get to the result. The kinetic energy, for example, of a grain of sand which is nearly accelerated to the speed of light, will be equal to the kinetic energy of an object weighing 100 tons that is falling from a height of a 15-story building. It is as if the largest part of the Statue of Liberty fell from its pedestal in one fell swoop. So, if a needle rushing at the speed of light strikes the Earth, will scientists have time to notice it? It's hard to say. But in a collision with the surface of our planet, all the kinetic energy will go into the energy of the explosion. The power release will be similar to the energy of a nuclear bomb, approximately 43 kilotons of TNT. And that's a lot. The bomb Fat Man dropped on Nagasaki had a capacity of about 21 kilotons. Just compare the two, an ordinary needle and a nuclear bomb that destroyed an entire city. In order to understand what kind of destruction such a collision can make, you need to choose a city. For example, New York. Where else should a needle moving at the speed of light strike, if not Manhattan? Cinematic alien invasions happen here. If an atomic bomb of the same power were dropped here, then most of Manhattan and the surrounding area will be destroyed. Even at a distance of 4 kilometers, or 2.5 miles, building windows would break. People who are a little closer to the epicenter would suffer serious harm. For example, all the inhabitants of Hell's Kitchen would get third-degree burns. Central Park will be almost completely burned. People who are within 1.5 kilometers, or less than a mile, of the place where the bomb falls are likely to die within a month. The needle bomb can also penetrate below ground, creating a huge crater with its explosion. And yes, the Statue of Liberty will definitely fall from its pedestal, perhaps right into the water. What about the big wave? There is another version of how this might go. It's less scientific but much more spectacular. I'm sure you'll want to see it. Crashing into the planet, the needle disappears into the Earth's crust. A plasma cloud will spread from the entry point to the sides. Energy will escape through the body of the planet, and along with it, many particles created by the collision with the Earth's crust. It will become a colossal explosion, a fountain of everything that our Earth is made up of. In a split second, it will become so hot that there will be nothing left alive on the surface. The energy will be so great that it will exceed the energy of the gravitational coupling of the planet. See what all this means. Explosion. The Earth will simply be torn apart faster than you have time to blink. However, there will be no one left to do so anyway. The solar system will change forever, and all because of some small needle. However, this whole situation is, of course, hypothetical. So there's an alternative point of view. Some physicists believe that because of too much kinetic energy and enormous inertia, the needle will simply pierce the Earth through, and this will happen so quickly that no one will even notice. The needle will come out the other side of the planet and continue its flight. Perhaps a person, due to interaction with the mantle in the Earth's crust, earthquakes will begin, but they are unlikely to be strong. Ultimately, humanity will easily survive whatever happens. But what if the needle doesn't strike the ground or even the water, but rather a person? The probability of this is quite small, but it's still there. It would seem that this is just like the Statue of Liberty which dropped on your head. Yes, and from the 15th floor. It sounds like it's impossible to survive. The kinetic energy of the needle will be very strong. If your body absorbs it completely, it will simply explode. But physics is a tricky thing. Due to the high energy and small size, the needle in contact with the skin will immediately begin to destroy all the bonds between cells. In this case, the rest of the body will feel almost nothing. The object will simply move through the body, dissipating a little of its energy into friction and slightly increasing your temperature. As a result, the needle will be able to make an almost perfect hole in your body. Not a single vital organ is affected, not seriously anyway, and the wound is likely to be cauterized. I'll try to summarize. Does it make sense to fear needles that travel at the speed of light? I think everyone will decide for themselves. But still, I hope that extraterrestrial civilizations are sufficiently developed and will so with the help of something else. If you liked the video, give it a thumbs up. Don't forget to subscribe to the channel if you haven't done so already. Click on the bell quickly to receive notifications of new interesting videos that are waiting for you ahead.